This videotape deals with solving first-degree equations and inequalities. Before we get into that, however, I'd like to spend a few moments discussing how we simplify algebraic expressions. This is basically a bit of a review. The key to simplifying algebraic expressions is, of course, the distributive law. You'll remember that for any real numbers, a, b, and c, a times b plus c, parentheses, is equal to ab plus ac. This is the distributive law. A times b plus c is a times b plus a times c. Now, this can help us to remove parentheses in an algebraic expression. For example, minus 3 times x minus 2. Using the distributive law, we would get minus 3 times plus x, or minus 3x, minus 3 times a minus 2, which is plus 6. So we can remove parentheses using the distributive law. We can also use the distributive law to combine like terms. Let's say we have 8x plus 3x. These are considered like terms since the variable part in each term, that is the x, are the same. They have different numerical coefficients, different constant parts, but the variable part of the term is the same. What we can do is factor out an x, like so. This is by the distributive law. 8 plus 3 times x is 8x plus 3x. And then, of course, 8 plus 3, that's 11. So we get 11x. Of course, most people, to combine like terms, simply combine the numerical coefficients and then put that before the variable part of the term. Okay, but really what we're using is the distributive law. Let's try another one. Let's say we have minus 4x plus 4x. This can be thought of as minus 4 plus 4 times x, which is 0x. Now with 0x, we can just write 0. 0 times x is just 0. Okay, with that under our belts, let's get into the job of actually solving first-degree equations. By that I mean an equation in which the highest power that the variable appears to is the first power. Okay, we have a basic property of equality which we'll be using to solve equations. These are the basic properties of equality. It says if we have an equation, say a equals b, then we can get an equivalent equation if we add a quantity, say c, to both sides of the equation. This is an equivalent equation in the sense that they have the same solution sets. Okay, we're allowed to add the same quantity to both sides of an equation. We can subtract the same quantity from both sides of the equation. And you can, if you have a non-zero quantity, you can multiply both sides of the equation by the same quantity or divide both sides of the equation by the same quantity. Here I'm going to specify that c is not 0. Okay, basically you can add the same quantity to both sides, subtract the same quantity from both sides, or if it's a non-zero quantity, multiply or divide both sides of the equation by the same quantity, and you will get an equivalent equation. These are all equivalent equations. If this is true, then these are also true. Okay, so let's use this idea. Let's say we have a simple first-degree equation, something like x minus 3 is equal to 8. First, let me give you a second if you want to copy this down. If a equals b, you can add the same quantity to both sides, subtract, multiply, or divide with this proviso, and get an equivalent equation. Okay, now, on a simple first-degree equation in one variable, okay, there's one variable involved here, x, the highest power that it appears to is the first power. It's a first-degree equation. The idea is to solve for the variable we would like to isolate the variable x. So we do this by saying, well, look, we have x minus 3 equals 8. We can add 3 to both sides of the equation. This will give us x alone on the left. Minus 3 and plus 3, that gives you 0, is equal to 11. This equation is equivalent to the one that we started with. And of course, in this form, you can read off the solution. You know that x equals 11 is the solution to the equation. And of course, you can check in the original problem. 11 minus 3 is, of course, equal to 8. OK, well, this was a very simple one. Let's work on one that's a little bit more complicated. 3x minus 5 is equal to 7x plus 7. Once again, we would like to isolate the x. Get x alone on one side of the equation. That's our strategy. OK, now it doesn't matter which side you decide to get the x alone on, either one. OK, let's say here we got it on the left. Let's say we decide to get x alone on the right. Okay, it means all the terms with x we'd like to move to the right side. Everything without x we'd like to move away from that side. OK, to start, we can subtract 3x from both sides of the equation. This will give us just minus 5 alone on the left is equal to 7x minus 3x. That's 7 minus 3x, or 4x, plus 7. We now have elect x only on the right side of the equation. Of course, we have other things there as well. We'd like to get x alone on that side, so we will subtract 7 from both sides of the equation. Okay, always be careful what you're doing here. If you have a plus 7, to get rid of it, in a sense, we will subtract 7 from both sides. Some people don't pay attention. They start dividing or whatever. Think about the operation and how you can undo. To undo this plus 7, I add on this. In other words, I take away the 7. Okay, you don't divide, you subtract. OK, over here, minus 5 and minus 7, that's minus 12, equals 4x. OK, well, we're almost there. We have 4 times x. OK, we would like to get x alone. So now we would divide both sides of this equation by 4. We would not subtract 4, but divide. To undo this multiplication, we divide. And that gives us that x is equal to minus 3. See what we have? We have minus 12 over 4. We just rewrite that line here. Equals 4x over 4. This is minus 12 over plus 4. This is minus 3 equals x. X equals minus 3 is our solution. At least we believe it is. Let's check it just to be careful. The original equation, if you'll remember, was 3x minus 5 equals 7x plus 7. So we take what we believe to be the solution, x equals minus 3, substitute into the original equation, and see if it works out. 3 times minus 3 minus 5 should be equal to 7 times minus 3 plus 7. Now on the left we have 3 times minus 3, that's minus 9, minus 5. That should be equal to minus 21 plus 7. And it works out because minus 9 minus 5, that's minus 14. And minus 21 plus 7 is also minus 14. And it checks. So we have found the solution to that equation. Let's try another one. 5 times x minus 3, in parentheses there, minus 2x equals 4x minus 20. I'd like to solve this equation. It's also a first-degree equation in x. OK, a little bit of work has to be done before we can get x alone. We're first going to have to simplify this by removing the parentheses, then combining like terms so that each side will only have, say, a term involving x and a constant. Then we'll get the x terms on one side, the constants on the other, and finish up. OK? So first of all, we remove the parentheses. 5 times x minus 3. According to the distributive law, it's 5 times x minus 5 times 3. Okay, the most common mistake that people make in a problem like this, of course, is to just write 5x minus 3. They forget to distribute the 5 all the way through the parentheses. Okay, not only the x, but also the 3 here. Both of them are going to be multiplied by the 5, giving us 5x minus 15 minus 2x is equal to 4x minus 20. Okay, now, on the left side, we notice we have like terms that we can combine. 5x minus 2x, 5 minus 2x, or 3x minus 15 equals 4x minus 20. Okay, let's get the x alone on one side of the equation. Let's say we want to get the variable, the x alone on the left side. So we subtract 4x from both sides of the equation, giving us 3x minus 4x, 3 minus 4, or minus 1x, or just minus x, minus 15 is equal to minus 20. Okay, then we can add 15 to both sides of the equation, giving us minus x is equal to minus 5. And remember, this is really like minus 1x. If we want to get x alone, we can divide both sides of the equation by minus 1. Minus x over minus 1, that becomes plus x, equals minus 5 over minus 1 is plus 5. And once again, we would like to check our equation. We go back to the original equation. We want to check that x equals 5 is the solution in the original equation, which is 5 times x minus 3 minus 2x is 4x minus 20. So we substitute in the x equals 5. We get 5 times 5 minus 3 minus 2 times 5 should be equal to 4 times 5 minus 20. Here we have 5 times 2 minus 2 times 5, which is 10, should be equal to 20 minus 20. And on the left, of course, we have 10 minus 10, which is 0, and on the right, 20 minus 20, which is 0, and it checks out. Okay, now I'd like to move on and show you how to solve first-degree inequalities. Before we get to that, I'd like to make sure we all understand what we mean by the basic symbols of inequality. Okay, if I write a symbol like this, this means less than. For example, 2 is less than 3. 2 is less than 3. If you were to draw a picture of the number line, okay, let's say this is 0, 1, 2, 3. If 2 is less than 3, okay, then 2 appears to the left of 3 on the number line. Okay, similarly, we can write 5 is greater than 1. This symbol means is greater than. 5 is greater than 1. On the number line, 5 is to the right of 1. So if one number is greater than the other, it is to the right of the other on the number line. If one number is less than the other, it is to the left of the other on the number line. Okay. We also have symbols like this, less than or equal. I can write that 3 is less than or equal to 4. This just means that one of these two have to hold true. This is a true statement. 3 is less than or equal to 4 because 3 is less than 4. This means is less than or equal to, not less than and equal to. That couldn't be true. Okay? But less than or equal. As long as either the less than or the equal holds, this is a true statement. And of course it is. I could also write 4 is less than or equal to 4. Because here 4 is equal to 4. So it is certainly less than or equal to because it is equal. Here 3 is less than or equal to 4 because it is less than. And we can also have a greater than or equal symbol. For example, 6 is greater than or equal to 3 because 6 is greater than 3. 3 is greater than or equal to 3 because 3 is equal to 3. Okay. All right, now what about something like this? Suppose I give you the numbers -3 and -2, and I ask you what we should put in between, a less than or a greater than symbol. Okay, you would write that -3 is less than -2 because the number -3 is to the left of the number -2 here on the number line. Although 2 is less than 3, when you have the negative numbers, it sort of works in the opposite order. -3 is less than -2. Okay, we would also write -1 is greater than -5. The number -1 is greater than the number -5 because -1 is to the right of -5 on the number line. Okay. So if you're not quite sure, you can always look at the number line and see which number is to the left. The number to the left of another number is smaller. It's less than the other number. Okay, now, let's say we have a first-degree inequality, something like this. 3x minus 5 is less than 7. We would like to solve this for x. Okay, now we have rules for solving equations. We don't have any yet for solving inequalities. Okay, you don't have to worry. A lot of the rules are going to work just the same way. Let's say I have an inequality something like this. -2 is less than 3. If I add a number to both sides of it, let's say I add 1 to both sides of this inequality, I get -2 plus 1. -1 is less than 4. I get an inequality which is also true. It is perfectly okay to add a number to the same number to both sides of an inequality. You could do it for equations. You can also do it for inequalities. Okay. Okay, if addition is okay, let's try subtraction. What if I subtract 1 from both sides of the inequality? I would get that -3 is, and here we have 2. -3 is less than 2, and of course, that is also correct. I'm subtracting 1 now from both sides of the inequality. -3 is less than 2. So I can subtract a number. At least it appears from what I've shown here that I can subtract a number from both sides of an inequality. That's also okay. Now, let's look at multiplication. What if I were to multiply? Actually, multiplication and division can sort of be taken at the same time. Let's say I was supposed to multiply both sides of the inequality by a number like +2. Okay, if you multiply both sides by +2, you get -2 times 2, 3 times 2. You get -4 is less than 6. This is also true. And division would also work similarly. You could dividing by 1/2, for example, is the same thing as multiplying by 2. Okay, now, something funny happens when we try to multiply both sides of the inequality by a negative number. Then we get something strange. Let's look at that. Okay, multiplying by a positive, everything was okay. Let's take the same inequality, -2 is less than 3, and multiply both sides by -2. Then you'd have -2 times -2 on the left and 3 times -2 on the right. Here we'd have a 4. Here we'd have a -6. Clearly 4 is not less than -6. 4 is greater than -6. It turns out that when you multiply or divide both sides of an inequality by a negative number, or negative quantity, you have to reverse the direction of the inequality. And that's basically, in a nutshell, the rules for working with inequality. You can do the same things you did when you're working with equations to solve, okay? You can multiply, you can add something to both sides, the same thing to both sides of the inequality, subtract the same thing from both sides of the inequality. If you want to multiply or divide both sides of the inequality by a positive number, that's also okay. But If you want to multiply or divide both sides of the inequality by a negative number, then you must reverse the direction of the inequality. If you remember that, working with inequalities is no harder than working with equations. So let me write that down for you as a rule, and then we'll go and try to solve a few of these. Rule. When solving an inequality, use the same methods as for solving an equation, except if you multiply or divide by a negative number. A negative number or a negative quantity, then I want you to reverse the direction of the inequality. When solving an inequality, use the same methods as for solving an equation, except if you multiply or divide by a negative number, reverse the direction of the inequality. Okay, let's start by working out this inequality that I gave you earlier. And the trick, once again, is to isolate x, get x alone on one side of the inequality. To do that, we could add 5 to both sides of the inequality. Perfectly okay to do that. We'd get 3x is less than 12. And then we would divide both sides of the inequality by 3. Now 3 is a positive number, so there's no trouble in doing that. Divide both sides of the inequality by 3. You get x is less than 4. Okay, as a solution. Okay, it's a nice idea to sometimes try to picture what the solution set looks like. One way of doing that would be to use a number line. The solution consists of all those numbers x that are less than 4. So if this is 0, 1, 2, 3, 4. Okay, we want to indicate that 4 is not in the solution set, but everything less than 4 is. What we can do is draw an open circle here at 4, and then an arrow moving off in that direction to indicate everything less than 4. If it had been less than or equal to 4, if 4 had been in the solution set, then I would have filled this in to indicate that 4 is in and everything less than 4. This means just everything less than 4. Not 4, everything to the left of 4, everything less than 4 is in the solution set. Okay, let's try another example. 7 minus 2x is greater than or equal to 11. Okay, I'd like to get x alone on one side, so I'm going to subtract 7 from both sides. That's perfectly okay. You get minus 2x is greater than or equal to minus 4. Excuse me, greater than or equal to 4. 11 minus 7, that's 4. Now, I'd like to divide both sides of this inequality by minus 2 in order to get x alone. Now, however, when I divide both sides by minus 2, I realize that minus 2 is a negative number, and therefore I must reverse the direction. If it's a greater than, you make it a less than. If it's greater than or equal, you make it less than or equal. Okay? So I've divided both sides by minus 2, but I've had to reverse the direction. Okay, right in here. Look at that. I reversed the direction. Okay, now, let's see what we have. Minus 2x over minus 2. Minus 2 over minus 2 gives you plus 1, so you just have x alone here, less than or equal to minus 2. And to indicate this on the number line, here's 0, minus 1, minus 2. I want all values less than or equal to minus 2. I will fill it in at minus 2 and then move off to the left. This indicates less than minus 2 or equal to minus 2. These are all in the solution set, minus 2 and below. Okay, notice the difference. When it was just less than 4, I had an open circle here. Just less than 4, it was not filled in. It was an open circle for less than 4. But less than or equal, I fill it in to indicate that minus 2 itself is a possible solution. Okay, if you plug in minus 2, you do get a true statement. You get 11 is greater than or equal to 11, which is true. And also anything less than minus 2 is also going to give you a true statement when you substitute in. Okay, let's try another one. 2 times x minus 4 minus 9x is less than 20. Okay, just like when we're solving equations, the first thing to do would be to simplify, okay, the left side here by using the distributive law to remove parentheses. We would get 2x minus 8. Not 2x minus 4, but 2x minus 8. You must send the 2 all the way through the parentheses. Minus 9x is less than 20. On the left side now we have 2x minus 9x. These are like terms. They combine to give you minus 7x. 2x minus 9x, that's the minus 7x, and less than 20. We then add 8 to both sides to get x alone on one side. We get minus 7x is less than 28. And now we would like to divide both sides by minus 7, but of course minus 7 is a negative number, and therefore we must reverse the direction. When I divide by minus 7, I will reverse the direction. Dividing by minus 7, you immediately reverse the direction. If you want to do it all in one step, fine, then cross it out and immediately put the greater than in. Okay, don't say you're going to do it on the next step because you'll never remember. It has to be done immediately. So then I get here, x is greater than minus 4. And to indicate this on the number line, say this is 0, minus 1, minus 2, minus 3, minus 4, greater than minus 4 would look like this. Not equal to, so it's an open circle, and then greater than minus 4, everything to the right of minus 4. For the last example, I would like to show you what we call a continued inequality, something like this. Minus 7 is less than or equal to 4x minus 3 is less than 13. Now you can, if you want to, break this up into sort of two problems and take the intersection of the solution sets. In other words, say minus 7 is less than or equal to 4x minus 3, solve that, and simultaneously you want to solve 4x minus 3 is less than 13. Okay, but a little easier way to do it is simply to treat it sort of as one continued inequality. If you can add the same number to both sides of an inequality, you can also do it if you have like a three-part thing like this. You can add it all the way across. So the trick here is to isolate x, but to get it alone in the middle. Okay, when you have a continued inequality like this, we want to get x alone in the middle of the inequality. So I'm going to add 3 to all parts of the inequality. And I will get minus 7 and plus 3, that's minus 4, less than or equal to 4x less than 16. I now want to get x alone in the middle, so I will divide through by 4. 4 is a positive number, and therefore I can keep the same directions. Don't get confused. Some people see a negative number like a -4 here, and they figure they should reverse some directions. Okay. It's what you're dividing by. I am dividing by +4. And since that's positive, I do not reverse my directions. This gives me -1 is less than or equal to x is less than 4. Had you worked them out separately, you would have found out that -1 is less than or equal to x, or x is greater than or equal to -1, and then you would have found out also x has to be less than 4. In other words, x has to be both greater than or equal to -1 and simultaneously less than 4. In other words, it's stuck between -1 and 4. It can be equal to the -1, although it's strictly less than the 4. All the solution set here is all x between -1 and 4, possibly equal to -1, but strictly less than 4. To indicate this on the number line, we'd have 0, -1, 1, 2, 3, 4, and I would do it this way. Everything from including -1, from -1 up to, okay, but not including 4. -1 less than or equal to x less than 4. Everything between -1 and 4, including -1, but excluding the +4. Okay, and that brings us to the end of this tape.